All right, good evening. So welcome back to trigonometry. We are going to try to figure out the sine of the inverse cosine of 63/65 plus the inverse tangent of 21/20. It says give exact values, okay? Which means you cannot just type this into a calculator and give me a decimal expansion. I want you to give me a fraction. That's what exact values means, okay? So I want you to give me a fraction for what this thing is. All right. So what we're going to do is we're going to draw two triangles. So I'm going to label a triangle A and we have a triangle B. All right. So because this inverse cosine is going to give me an angle, we're going to call that A. This inverse tangent is going to give me an angle. We're going to call that one B. So what I'm going to do is I'm going to say, well, we have angle A is equal to the inverse cosine of 63/65. And then I'm going to kind of approximate doing a cosine is equal to 63/65. Now, when you've done your inverse trig functions, you know it doesn't quite work that way. It does in the first quadrant. So we're going to pretend that this stuff is in the first quadrant. Okay, so let's go ahead and label our triangle. So we're going to say cosine, and this is 63/65. Okay, and we have to figure out the rest part of the triangle. So we have to remember a squared plus b squared is equal to c squared. Which one's c squared? That's going to be 65. And that's equal to 63, a for adjacent, plus b squared. And our job now is to figure out what b is. So we're going to say we need a squared here. Okay, so we need that b squared is equal to 65 squared minus 63 squared. I'm going to get the calculator out in just a moment to do that. If I didn't have a calculator, I guess I could do my values of 65 minus 63. We could always do this, right? 65 minus 63, 65 plus 63, because it's a difference of two squares. But I'm going to go ahead and get the calculator out and have this work with this. Okay. I'm not going to use anything on this calculator that requires me to do something fancy because you guys are not allowed to use a fancy calculator. So the rules for me are you're not allowed to use anything fancy. But since this calculator actually shows up on screen, this is why I like to use this. So we have that b squared is equal to 256, and that means that b is equal to 16. So this guy right here is 16. All right. There's another triangle here. We have that b is equal to the inverse tangent of 21/20. So we're going to say that tangent of b is equal to 21/20. Again, that's not exactly the way that inverse trig functions work, but we're going to say it's first quadrant, and this is how we're going to go through the problem. So we have opposite over adjacent, so 21/20 for the tangent. This is my angle B. And then we can go ahead again. We know two sides of the triangle, so 20 squared plus 21 squared. I don't know these. 400 plus 441. And then we have to add those together. We have the square root of 841. And to be honest, I don't think I actually got this far with my squares to be able to know what the square root is. So what is going to be, so we're going to say our C is equal to the square root of 841. I think it's 29, but let's double check. Okay, so we'll go ahead and say clear. We want second function square root of 841. Okay, equals, oh, look at that, it is 29. Okay. Okay, so there we go. On your exam, these will be what they call Pythagorean triples. So there shouldn't be a lot of square roots or anything like that because these problems are long enough as it is. We don't need to make them longer by adding a bunch of square roots in here. Okay, so we have our triangle A, we have our triangle B, and what are we trying to figure out? We're trying to figure out the sine of A plus B. Let's go ahead and write this down again. We have the sine of A plus B. You have to have the sum of angle formulas memorized. This is going to be the sine of A, cosine of B, plus the cosine of A, sine of B. Sine, cosine, cosine, sine. Okay, that's pretty much how that goes. Okay, looking at triangle A, what is the sine of triangle A? That's going to be 16/65. Okay, so we're going to say this is 16/65, and then we need the cosine of B, which is 20/29. Okay, so here we go. It's 20/29 plus, and now we have to do the cosine of triangle A. That's this first one over here. Okay, and that's going to be the cosine. We need 63/65. Okay, so here we go. 63/65 times, and here we have the sine of B. So the sine of b is going to be 21 29ths. Okay, so here we have 21 29ths, right? And then we're going to go ahead and figure this thing out. Okay, so I need 16 times 20, which looks like it's going to be 320, but let's go ahead and double check it. So we have 16 times 20 equals, and there's a 320. I'm going to hold that off for a side here. 63 times 21 equals, we have 1323. Notice that the denominators for both of these fractions is 25 or 65 times 29. So we don't have to worry about doing that twice. So that's going to be easy. And then here we go. It's 1885. 85. Okay, so we're going to say we have 320 plus, what is this, was 1323. There we go. 1323. And we have 1643 over 1885. That is my exact value for what the sine of this whole thing is actually going to be. All right. So when you're doing this problem, it's not a calculator exercise. It is you draw the triangles, unravel the sum of angles formula that you're going to be using, calculate out the triangles that we're looking for, and then voila, there you go. You'll have it. Okay. So I'm going to say thank you very much for watching the video here, and I will see you in the next one. Good luck.